Answer the following questions. Question 1. Choose the correct answer. 1. If 5 power x equals 2, then 25 power x equals 10, 6, 5, or 4. Solution. We know that 25 power x equals 5 power 2 all power x, as 25 equals 5 power 2, and we can write 5 power 2 all power x in the form 5 power x all power 2. But we know that 5 power x equals 2, so we substitute 5 power x equals 2, so we have 2 power 2, which equal 4. So the answer is D. 2. The shape which represents y is a function of x is one of these 4 figures. Of course, figure A, the first figure, it doesn't represent any function because we have two images to the point 1 and the negative 1. So A is refused. It doesn't represent any function. Also, figure B doesn't represent any function because we have 2 points 1 and 2, 1 and the negative 2. So the point 1 have two images, 2 and the negative 2. And this figure C, this is a function because every point, or you can say every element in the domain, have only one image in the codomain. So the image of the point 1 is 1, the image of the point 2 is 2, the image of the point negative 1 is 3. So this figure C represents a function. Figure 4 does not represent any function. Figure D does not represent a function because the element 1 has two images, negative 1 and 1. We have these 2 points, 1 and the negative 1 and 1 and 1. So figure D does not represent a function. So solution, the shape which represents y is a function of x is the shape C, this figure. 3. If the curve y equals log 1 minus ax to the base 4 passes through the point 1 over 4 and the negative half, then a equals 2, 3, 4, or 8. Solution. First, we write the logarithmic form, we write it in exponential form. So we have 4 power y equals 1 minus ax, and we write it 4 power y equals 1 minus ax. But this function satisfies this point, or you can say the point 1 over 4 and the negative half lies on the curve of this function. So when y equals negative half, x equals 1 over 4. And you can say when x equals 1 over 4, so y equals negative half, and we substitute. So 4 power negative half equals 1 minus 1 over 4a, substituting x equals 1 over 4. And we solve this equation to calculate a. Then half minus 1 equals negative 1 over 4a, as 4 power negative half equals half. 4 power negative half equals 1 over 2. Half minus 1 equals negative half, so negative half equals negative 1 over 4a, and calculating a equals negative half divide negative 1 over 4, which equal 2, and the answer is a here. a equal to. From the following functions, the one-to-one function is, we have four functions, f1, f2, f3, f4, and the question is which one of these functions is one-to-one. Solution: f1 is a linear function, f2 is a quadratic function, f3 is absolute function, and this is a constant function. When you draw a straight line, a horizontal straight line, it will cut the quadratic function at 2 points. So f2 is not one-to-one function. Also, when you draw a horizontal line, it will cut the absolute value function at 2 points. Also, with respect to f4. So f1, it is a linear function. Any horizontal line, it will cut it at only 1 point, as follows. When we draw this function by choosing some points, take x equals -2, so -2 plus 2 equals 0. So the point -2 and 0 lies on the curve of this function f1. Take x equals 0, substitute x equals 0, so 0 plus 2 equals 2. So 0 and 2 is a point lies on this straight line. So we draw this straight line and we draw a horizontal line. Any horizontal line, it will cut the curve at only 1 point. So the one-to-one function is f1 of x, and the solution is A. The answer is A. The horizontal straight line cut the curve of the function at only 1 point. Question 2. 1. Determine the domain of each of the following functions. We have two functions, f of x and g of x. F of x equals x over root 1 minus x. So we solve A. We start with A. 1 minus x must be greater than 0. Of course, not equal 0, because the root on the denominator and the division by 0 is meaningless. So 1 minus x must be greater than 0, and we write 1 minus x is greater than 0, and we solve this inequality. The solution set of this inequality will be the domain of f of x. So negative x is greater than -1. Multiplying both sides by -1, we have x is less than 1. When you multiply the inequality by a negative number, we will change the direction of the inequality. Here is negative x is greater than, we have x is less than 1. So solution set of this inequality equals open interval -1 to 1, and the domain is the same solution set, equals negative infinity and 1. B, we have g of x equals x minus 1 over x minus 1 multiply x plus 1 plus 1 over x plus 1. We factorize x square minus 1 as a difference of two squares, x minus 1 multiply x plus 1, and don't cancel x minus 1 with x minus 1, because we determine the domain. The domain of first fraction is r difference 1 and the negative 1, and the domain of the second fraction is r difference negative 1, because negative 1 makes the denominator equals 0. So the domain equals r difference 1 and negative 1. If f is a function where f of x equals x squared when x greater than 0, and the f of x equals negative 2x when x is less than 0, graph the curve of the function f, and from the graph find the range of f. So f of x equals x squared when x is greater than 0, and the f of x equals negative 2x when x is less than 0. For that, we draw a table. You can make it a horizontal table, substituting some points in this domain. And we take another point in this domain. For this, we take x equals 0 here, but it will not belong to the curve of the function, because x is greater than 0. Also, x is less than 0. So when after we represent this point 0 and 0, we put a circle to express that the point 0 and 0 does not belong to the domain, and also does not belong to the range. So we take some points, negative 5, we substitute it in the second branch. When you put x equals negative 5, so f of x equals 10. Negative 2 multiply negative 5 equals 10. We take another point, negative 4. Negative 4 multiply negative 2 equals 8, and so on till you get 0. Substituting 0, negative 2 by 0 equals 0. To represent the first branch, we take some values greater than 0. 1 and 1, because 1 power 2 equals 1. So when x equals 1, f of x equals 1. When x equals 2, we have f of 2 equals 2 power 2, which equal 4, is the same to 3 if f of x equal 9 when x equals 4. So f of x equals 16. And we draw a curve or a graph for each branch. The second branch here represented by this ray starting from the 0 to infinity, because x is less than 0. And the second branch here, it's a part of quadratic function. It is a part of quadratic function. Here we use a ruler to draw this part, and don't forget to put this circle to express that the point 0 and 0 does not belong to the range, and also does not belong to the domain. So the required here also to find the range. So the range of the function equals the open interval 0 to infinity. From 0 to infinity. From the smallest value of y coordinate to the greatest value. But 0 doesn't include it, so we put open interval. Question 3. 1. If f of 1 from R to R, where f1 of x equals 3x minus 1, and f2 is a function, its domain negative 2 to 3, to R, its codomain, where f of 2 of x equals 3 minus 2x. Then graph the function f1 plus f2 of x, showing its domain, then check its monotony. So f1, it's a function from R to R. Here is the domain, and R here is the codomain. And the rule of f1 is 3x minus 1, and the rule of f2 is f2 of x equals 3 minus 2x. Solution. First, we write f1 plus f2 of x equals 3x minus 1 plus 3 minus 2x. 3x minus 2x equals x, negative 1 plus 3 equals 2. So how we get f1 plus f2? We add 3x minus 1 plus 3 minus 2x, and the result, x plus 2, express a new function f1 plus f2 of x. The codomain equals d1 intersect d2. The codomain of f1 and f2 equals the domain of first function intersect the domain of the second function. The domain of the first function is R, and the domain of the second function is negative 2 to 3, closed interval. And their intersection equals the interval negative 2 to 3. The function is increasing on its domain. We deduce it from the figure. As x increase, y is increase. So the function is increasing on its domain. The function is increasing on its domain. Notice that when x equals negative 2, y equals 0. When x increases to be 0, y increases to be 2. When x equals 3, y increases to be 5. So y always increasing. So the function f1 plus f2 is increasing on its domain. Question 3, second part. Find the inverse function of the function y equals x plus 1 and graph them on the same figure. Solution. Y equals x plus 1. By replacing the letters, we get first step, replace the letters. Instead of y, we write x. Instead of x, we write y. And we put y as a function in x. So we have the inverse function is y equals x minus 1. And we draw it. We draw the first function, y equals x plus 1. Here, y equals x plus 1. And the second function, the inverse function, y equals x minus 1, we draw it. The inverse function, y equals x minus 1, is the image of the function y equals x by minus 1 by reflecting on the straight line y equal x. This is the relation between the function and its inverse. Both are the image by reflecting on the straight line, this dashed straight line, y equal x. Question 4. Find in R the solution set of each of the following equations. A. Logarithm x to the base 4 equals 1 minus logarithm x minus 3 to the base 4. B. Absolute of x plus 2 equals absolute of x minus 3. First, we solve A. We have logarithm x to the base 4 equals 1 minus logarithm x minus 3 to the base 4. Logarithm x to the base 4 plus logarithm x minus 3 to the base 4 equals 1. Put it from right hand side in left hand side. Its sign is negative. In left hand side it will be positive. And we change the addition to multiplication. So we have logarithm x multiply x minus 3 to the base 4 equals 1. And we write it on the exponential form to be 4 power 1 equals x multiply x minus 3. X multiply x minus 3 equals 4 power 1. And we solve this equation to find x. So x multiply x equals x square minus 3x equals 4. And we put it as a 0 equation. So we write x squared minus 3x minus 4 equals 0. And we factorize it to be x minus 4 multiply x plus 1 equals 0. When x minus 4 equals 0, so x equals 4. When x plus 1 equals 0, so x equals negative 1, and this is a refused answer because there is no logarithm for a negative number. So x equals negative 1 is refused. And the solution will be x equal 4. Here we have absolute of x plus 2 equals absolute of x minus 3 by squaring both sides. We have x squared plus 2x plus 4 equals x squared minus 6x plus 9. So we write it x squared plus 4x plus 4 equals x squared minus 6x plus 9. And we simplify these both two terms to be 10x equals 5. X squared minus x squared equals 0. And 4x plus 6x equals 10x. And 9 minus 4 equals 5. And x equals 5 over 10, which equal half. And this value satisfy both sides, both the equation. When you substitute x equals half on this equation, we have two equal sides. So the solution set equals half. Here the solution set equals 4. 2. Use the curve of the function f of x equals x squared to graph each of the following functions. First, f1 of x equals x squared minus 3. B, f2 of x equals x squared plus 3. f1 of x is the image of x squared by translation 3 units on the negative direction of y-axis. Also, f2 of x equals x squared plus 3 is the image of f of x equals x squared by translation 3 units on the positive direction of y-axis. Here is negative 3 and here is plus 3, minus 3, plus 3, and we draw it and we write this. This is the first curve here is f of x equals x square. F of x equals x square. And this curve to represent f of x equals x square plus 3. Here, the third curve, f of x equals x square minus 3. And we write it. And f of x equals x square plus 3. F of x equals x square. F of x equals x square minus 3. It passes through the point 0 and negative 3. Passes through the point 0 and 0. Passes through the point, and the curve of the function f of x equals x square plus 3 passes through the point 0 and 3. Question 5. Find the solution set of the inequality absolute of 3x minus 2 is greater than or equal 7 in R. 2. Find in R the solution set of the equation x power 4 over 3 minus 10 power 2 over 3 plus 9 equals 0. First, the solution for this inequality, it's two branches. 3x minus 2 is greater than or equal 7, or 3x minus 2 is less than or equal negative 7. From this, we have 3x is greater than or equal 7 plus 2, which equal 9. So x is greater than or equal 3, as 9 divide 3 equals 3. And 3x minus 2 less than or equal negative 7. It means the 3x is less than or equal negative 7 plus 2, which equal negative 5. And from this, we deduce that x is less than or equal negative 5 over 3. So the solution set equals R, except the open interval negative 5 over 3 and 3. With respect to 2, we have x power 4 over 3 minus 10 x power 2 over 3 plus 9 equals 0. And we factorize this equation to be x power 2 over 3 multiply x power 2 over 3. X power 2 over 3 multiply x power 2 over 3 equals x power 4 over 3, same denominator here. And 9 equals negative 1 multiply 9. And their sum, negative 1 plus negative 9 equals negative 10. So x power 2 over 3 minus 1 equals 0. Then x equals positive or negative 1. Or x power 2 over 3 equals 9. And we deduce that x equals positive or negative 3 power 2, 3 over 2, which equal positive or negative 27. Again, how we solve this equation? We write 9 as 3 power 2. To get rid of 2 over 3, we raise both sides to the multiplicative inverse of 2 over 3, which is 3 over 2. So x power 2 over 3 all power 3 over 2 equals x power 1, positive or negative. 9 is 3 over 2. It raised to 3 over 2, which equal positive or negative 27. And the solution set equals 1, negative 1 from the first solution, 27 and negative 27 from the second solution. And this is the end of the exam. I hope you understand everything. Goodbye and good luck.